So again, welcome to my channel. Here, I'm going to solve second test paper of data science, which includes making of decision tree. Okay, so let's get started. I'm reading the question, which is related to first internal test. I'm going to read the question. ID3 algorithm decision tree solved examples, machine learning, problem definition. They build a decision tree using ID3 algorithm for the given training data in the table by computer data and predict the class of the following new example, which is age is where age is less than 30, income is medium, student yes, credit rating fair. Here's the table which contains four attributes, or you can say five attributes: age, income, student, credit class, and bias computer is the main class. First, here is a solution. First we check the attribute provides the highest information gain in order to split the training set based on attribute selection method. We need to calculate the expected information to classify the set and entropy of each attribute. We first have to calculate each entropy of each attribute, then we select the root node from this attribute. Now, first we find the information gain is the mutual information minus the entropy. The mutual information of the two classes. Here we use the enthalpy gain or entropy gain method here. Information gain method here. First we now select now consider the first we consider the age attribute because it is the first attribute of this table. Now we calculate this information gain using the formula of information gain. For age, we have three values: age 2 years, 3 no, age 4 years, 0 no, and age 3 years, 2 no. Now, the entropy of age is finally calculated as 0.2465. We use 4 decimal precision here. Next, we consider the income attribute, which is the second attribute of this table. Now, for income, we have three values: income high 2 years, 2 no, income medium 4 years, 2 no, income low 3 years, 1 and we use the information gain formula to calculate the information gain or entropy of this particular attribute. The attribute is the value is 0.9108. Here as we also use the four decimal precision. Next, the gain is 0.0292. Next one, the third attribute we use is the student attribute. For student, we have two values: student yes, student no. So 6 yes and 1 no, 3 yes and 4 no. Now, entropy of student is using the formula we calculated as 0.1516. Finally, we consider credit rating attribute, which is the fourth attribute or the last attribute of this table. For credit rating, we have two values: credit rating fair and credit rating excellent, where we get 6 years in 2 no and 3 years in 3 no respectively. Here, entropy of credit rating equals to 8 by 14 minus 6 by 8 log. We use the same formula of information gain to calculate this entropy in this attribute, and we get the answer is 0.4790. Now we compare all the answers or all the values of four attributes. Which one has, which attribute has maximum information gain? We use that particular attribute. Here we can say the age attribute has maximum information gain, so we consider it as root node of the binary tree or decision tree. Okay, so here we make age as this age as root tree. Since age is the highest information gain, we start splitting the dataset using the age. So we start splitting the dataset from this attribute. Now we consider three attributes assigning to this age attribute. First, decision tree after step 1. Since all records under the branch age 31, 40 are all of the class, yes, we can replace the leaf with class yes. Okay, we can replace, now we replace this. Now build the decision tree for left subtree. In step, in same process of splitting has to happen for the two remaining branches: income, student, credit rating, and class. For branch age is less than 30, we still have attributes income, student, and credit rating. Which one should be used to split the partition? Again, again because it contains the entropy, so we again split this type of table, and we get that the mutual information is we use the formula of information gain again. And for income, we have three values. Entropy of income is 0.4, and gain of income is 0.57, and gain of student is 0.97. So 0.97 is greater than 0.57. So we select student as next leaf node, or you can say next root node of the age. We can then satisfy or safely split on attribute student without checking the other attributes since the information gain is maximized. So after age, we make student as a root attribute, and we consider income student and income student grade rating as the child classes. Decision tree after step 2. Since these two, after step 2, the decision tree look like this. Are from distinct classes, we make them into leaf node with their respective class as label. Here is the decision tree after step 2. Now, in step 3, we build the decision tree for right left subtree. We have considered the left subtree, now we consider right left subtree. Where income student crediting class is the table. We first calculate the information gain of income, it is 0.02, and calculate the information gain of student, which is 0.02, which is same as gain of income. And we now calculate the credit rating information gain, which is 0.97, which is greater among all the attributes. Now we consider the credit rating as the root node after the student node. Now after third iteration, the decision tree look like this. This is a final decision tree which we obtained from this question of this table. So keep the important points here. Decision tree for bias counter, new example age less than income, student yes, rate rating fair, hollow branch age is less than 30, then student yes, we predict class yes. Bias counter yes. So hope you guys understand the question solving and the formula and the method. Hope you guys understand, and thanks for watching my video. Thanks a lot.